lens. In this video, we will know about the rules of image formation for spherical lenses, that is convex lens and concave lens. When a ray of light is incident on a lens, then after refraction, the path it follows, those are made into rules. There are three rules of image formation for spherical lenses. When we know the rules of image formation, then with ease we can draw all the ray diagrams for spherical lenses. For drawing any ray diagram for image formation, a minimum of 2 incident rays are needed, which on refraction intersect at a point which will be the location of the image. So these incident rays follow these rules that we are going to discuss now. Now let us discuss the first rule of image formation. But before that, the diagrams that are there on the screen, in this the horizontal line is the principal axis and the vertical line is known as the optic axis. The point of intersection of the principal axis and optic axis is known as optic center. Now the first rule of image formation for spherical lenses is, let us begin with convex lens. In case of convex lens, if a ray of light is incident parallel to principal axis, then after refraction it passes through a point on principal axis that is known as the principal focus. Though for a lens there will be two focal points, one in the left side and one in the right side for both the lenses. In case of convex lens, the ray of light that is parallel to principal axis, after refraction it passes through the point. That point will be known as the principal focus. So, principal focus for convex lens lies towards the right side. That means like this, if I draw a number of parallel light rays, parallel incident rays, all of these after refraction will pass through this point which is known as the principal focus. That means parallel beam of light rays after refraction will converge through or converge to a point on principal axis. That point is called principal focus. So we can call a convex lens as a converging lens. And in case of a concave lens, when a ray of light is incident parallel to principal axis, then after refraction it appears to have diverged from a point on principal axis known as principal focus. That means in case of concave lens, principal focus lies to the left of the lens, though the other side also there is a focal point. Now like this, if we have a number of parallel incident rays, then all those rays will appear to diverge from the principal focus. That means concave lens, parallel beam of light rays. In case of concave lens, parallel beam of light rays after refraction appear to diverge from a point on principal axis called principal focus. So concave lens can be called as a divergent or diverging lens. So concave lens is a diverging lens. One more point, that for convex lens, the principal focus is in the right side. So the focal length, if we take sign conventions, focal length is in the right side. Principal focus is in the right side. So focal length is a distance between optic center and principal focus. So focal length has to be taken as a positive. And in case of concave lens, principal focus is in the left side. Distance between optic center and principal focus is called focal length, and focal length has to be taken negative. Why? Because all distances towards the left of the lens are taken negative and all distances towards the right of the lens are taken positive according to the Cartesian sign conventions. So we will remember that for convex lens, principal focus is in the right side, and in case of concave lens, principal focus is in the left side of the lens. Now let us see the second rule of image formation. In case of convex or converging lens, when a ray of light is incident through focal point, when a ray of light in case of convex lens is incident through focal point, then after refraction it goes parallel to the principal axis. And in case of concave lens or a diverging lens, according to the second rule, when a ray of light is incident in the direction of focal point, then after refraction it goes parallel to the principal axis. This is the second rule of image formation. Now let's see the third rule of image formation. When a ray of light passes from one medium to another and another medium to another, the ray of light bends. That is what is meant by refraction. Now, according to third rule, when a ray of light is incident on a convex lens through optic center, when a ray of light is incident through optic center, after refraction it goes undeviated. That means the incident ray and the refracted ray are in the same straight line. That means the ray of light doesn't appear to have deviated from its actual path at all. That means this is the case where Snell's law fails. Snell's law fails means the ray of light have appeared as if it has not bent at all. But keep in mind there are air to glass and glass to air. So in midst some deviation must have occurred, but the incident ray and the refracted ray finally fall in the same straight line. And in case of concave lens also, when a ray of light is incident through optic center, then after refraction it goes undeviated. That means it goes in a straight line. These are the three rules of image formation for spherical lenses.